In this episode, we look at how 5G stays RF clean, managing spurious emissions and ensuring coexistence with other systems like GPS, Wi-Fi, and satellite services. These controls are critical to avoid interference and maintain spectrum harmony. FR3 falls between FR1 and FR2 and is for 6G. Spurious emissions are unwanted RF signals radiated outside the assigned frequency band. They include harmonics, intermodulation products, and leakage from transmitter circuits. 3GPP sets strict spurious limits to prevent interference with neighboring systems. This is the spurious emission performance of an RF transmitter I tested. The main signal is around minus 30 dBm, and all the small peaks you see, higher or low, are spurious emissions. The highest spurious, marked as Mark II, is about minus 75 dBm, roughly 45 dB below the wanted signal. This is a typical result for a well-performing transmitter. By the way, the spurious is tightly related to the wanted signal level. The higher of the wanted signal level, the higher the spurious you will see. Spurious emissions limits are defined in 3GPP-TS 38.101 and 38.104 for UEs and base stations. Regulators like FCC, ETSI, and ECMA may impose even stricter out-of-band and conducted emission requirements. Typically, emissions must be below minus 30 dBm in specified frequency ranges. For real use case like to import RF transmitter to some countries, you need to pass the type approval tests, which is stricter than 3GPP requirements. For example, 3GPP defines minus 30 dBm for spurious emission. Other regulators need minus 36 dBm or even minus 40 dBm for spurious. 5G operates across diverse bands, FR1 and FR2, close to systems like GPS, 1.5 GHz, Wi-Fi 6E, 6 GHz, and satellite uplinks. Poor filtering or intermodulation can cause interference in these neighboring bands. That's why RF coexistence testing is vital, especially for multi-band and multi-rate devices. Hardware design plays a major role in emission control. Duplexers, filters, and power amplifier linearization help suppress spurious components. Digital techniques such as DPD, digital predistortion, also improve spectral purity. RF conformance testing checks both conducted and radiated spurious emissions. Measurements are done in shielded chambers or over-the-air setups using spectrum analyzer and near-field probes. Consistent compliance ensures devices don't disrupt existing wireless ecosystems. Spurious emissions and coexistence are at the heart of responsible RF engineering. They protect spectrum users and keep our networks running smoothly. In the next episode, we'll see how all these parameters come together in RF testing and conformance processes. That's all for today. If you like this video, please subscribe, share, and like. Thank you.